Hi, welcome back to General Chemistry 1. I'm Dr. Fang Xu. In this video, we're going to talk about resonance structures. So resonance structures or resonance forms are multiple Lewis structures that are both or all possible for a molecule. So sometimes there are multiple ways to write the Lewis structure for a molecule, and we call those resonance structures. Those are equivalent to each other. For resonance structures, they are connected by a two-headed arrow between them. So let's take a look at an example. Write the Lewis structure of O3, ozone. We can use two methods described in the previous video to write the Lewis structure of O3. So first, we'll come up with this structure. The three oxygens are connected between each other with a single bond, and we put six dots on terminal oxygen atoms and 2 dots on the middle oxygen atoms. However, the formal charge is not ideal, so we need to rearrange the Lewis structure to make a double bond and make a formal charge more ideal. Now the question is, how are we going to do that? We can move a pair of Lewis dot from the left oxygen to form a double bond between the first and second left and the middle oxygen atoms. Or we can move a pair of Lewis dot from the right oxygen and to form a double bond between the right and central oxygen atoms. These two structures are labeled 1 and 2. Both of them are very stable, and they are equivalent to each other. In other words, the middle oxygen can either form a double bond with the left oxygen or right oxygen. They are all the same. Okay, so when we refer to the resonance structure, we can write the structure 1 and 2 together with a two-headed arrow between them. Okay, so we also like to talk about bonding in resonance structures. As I include ozone, the resonance structures of ozone here, but I would like you to know that resonance structures are not real bonding depictions, which means usually the double bond, if it's just oxygen-oxygen bond, the double bond should be stronger than the single bond, which means the double bond should be shorter than the single bond. And that will lead to different bond lengths between central oxygen with two sides of terminal oxygens. However, in the reality, ozone does not change back and forth quickly from 1 and 2. So it does not do that. In reality, what it does is the structure called the resonance hybrid. It's an average of the resonance structures. In other words, the ozone will have this structure. The central oxygen has 2 Lewis dots. Both terminal oxygens will have 4 electron dots. Okay, then we put a dash line going across from the left oxygen to the middle oxygen to the right oxygen. That dash line means these electrons does not belong to any one of them. The electrons here belongs to all of them. We call that delocalized electrons. And that means the bond length between the central oxygen and the left oxygen, or the central oxygen and the right oxygen, are the same. Please make sure you understand the real length of the bonds of resonance structures. So all bonds are actually the same length here in the resonance hybrid. Another example is a famous benzene structure. So benzene structure is a ring structure. When we write the chemical structure, we write an alternative of single and double carbon-carbon bond. And it has different resonance structures. As you can see, this double bond, a pair of electrons in the double bond can jump between, so they can switch between the position of double bond and single bonds. So in reality, we have the resonance hybrid. Actually, those electrons are shared by all of the 6 carbon atoms in the ring. So those carbon-carbon bonds have the same bond length, kind of in between the single bond and the double bond length. All right, this is the end of this video, and I'll see you next time.